Hello, and welcome to another episode of Explain It Simply. Today, we're going to talk about how spaceships work. Imagine standing on a launch pad. In front of you, a huge rocket full of fuel is ready to launch. The sound of the engines vibrates the ground. The fire from the engines lights up the sky, and suddenly, the spaceship starts to rise. But how exactly does this happen? How does it escape from the Earth? And what happens out there in the vacuum of space? Let's explain it simply. The Earth doesn't let anything escape easily. With the force of gravity, it pulls everything towards the ground. And if we want to escape, we have to reach a terrifying speed, 40,000 kilometers per hour. This means that a spaceship must be 100 times faster than a passenger plane. No ordinary machine can achieve this. That's why we need rockets. Rockets work in a very simple, yet powerful way, based on the principle that every action has an equal and opposite reaction. For example, if you throw a ball forward, your hand feels a small force pulling back. Now, imagine that force a billion times stronger. Rockets burn fuel and shoot hot gases backward. This force pushes the spaceship upward. The more fuel it burns, the faster it goes up. But there's one problem. The fuel runs out quickly. Have you ever noticed that rockets don't stay whole when they launch? If we kept them together, they would become too heavy. So, once the first section of fuel runs out, the empty section is discarded. The first stage provides the most thrust and then falls. The second stage takes over, lifting the craft even higher. And finally, the third stage places it in orbit. This is how rockets achieve something almost impossible, defeating Earth's gravity. So the spacecraft has left Earth, but now there's a new problem. There's no air in space. This means there's nothing to push the craft forward. If we were on a highway, we could hit the brakes or the accelerator. But here, there's none of that. So, how does a spacecraft move in a vacuum? Here, things work differently than on Earth. Once something gains speed, it will keep moving forever unless something stops it. If a ship wants to speed up, slow down, or turn, it uses small maneuvering rockets. But for long journeys, regular rockets are impractical. The fuel runs out quickly. That's why scientists developed ion engines. Instead of burning fuel, these use electric fields to accelerate ions and create thrust. These engines are much more efficient, although they operate more slowly, but they are ideal for missions to distant planets, such as Mars. Sooner or later, every spacecraft has to return. But this return is dangerous. Imagine an astronaut returning in a capsule from the International Space Station. If the capsule were to fall without control, it would enter the atmosphere at a terrifying speed and be destroyed by friction. That is why small rockets are used to slow down the descent. So when the craft enters the atmosphere, it moves so fast that it rubs against the air and heats up to 1,500 degrees Celsius. To protect itself, it has special heat shields that absorb the heat and gradually crumble. Once the craft reaches lower altitudes, it deploys parachutes to slow it down even more. Finally, it falls gently into the ocean, where ships are waiting to collect it. If you think about it, a spaceship's journey is like an epic adventure, a battle with gravity, a journey into space, and a perilous return. Once upon a time, going to space was a rare and extremely expensive thing. But today, new technologies are available. Let's look at a few. Reusable rockets. Now, instead of being destroyed, rockets are returned and reused, reducing the cost of missions. High-voltage nuclear engines, they can get us to Mars much faster, instead of months or years. In the future, we may have permanent bases on the Moon or Mars, where spacecraft will be parked, like at airports. Space is no longer an elusive dream. It's humanity's next step. Spaceships are not just machines. They're tickets to the future. The next generation of astronauts may not even be professional astronauts. They could be tourists, scientists, even you. The question isn't if we'll travel to space. The question is when.